What's up guys, 8-Bit Wizard here, and today I'm bringing you a Python basics tutorial over lists. And again, as always, if you have any questions, comments, concerns, comment down below and I will get to them as soon as I can. Again, if you have any suggestions on how to improve these videos, what I can do to help you guys, let me know and I will go ahead and take your feedback and try my best to improve the videos for you guys. Anyways, so this video, as I mentioned, is over lists. And what lists are, they're defined by these square brackets right here. So right now we have a variable called squares, and it holds the value of a list with these numbers in it, right? So we can print it out. Squares, boom. Lists also support indexing, so there's different data types and different data types support indexing. Lists is one of them. So, boom. You can also slice lists just like you can strings. Lists also support operations like concatenation, so unlike strings, which are immutable, lists are mutable, meaning that it is possible to change their content. So let's set another variable with and assign it a list. Now, to change a value, we can call the variable the index we want to change and then assign it the new value. And if we print it out, we can see that it has been changed. You can also add new items at the end of the list by using the append method. So cubes dot append, you can type in the number or data type that you want to append. You can also use methods operations and append those. So 7 to the power of 3, and it works just as fine. Assignment to slices is also possible, and this can even change the size of the list or clear it entirely. So let me show you what I mean by that. So we'll say A, B, C, D, E, and we'll do F, just to give us a good sized list, and then print it out. Everything is good. So what we can do is replace the values. So we can do letters. We want the second to the fourth, so up to but not including, equal to, and we'll say C, D, and E. So when we do that and we call it, as you can see, it was changed. Now we can also remove them. So how you do that is you just slice the list right here. So slice the data type. However, it has to be able to be mutable, so meaning that it can be changed. So list is one of them, so you can slice them and then just set it to an empty list. When you call it, they're removed. You can also clear all the elements just by doing first index to the last and setting it equal to an empty list. And if we assign it some more values, we'll say A, print it out, just to show you there's a value in there. We can also just assign it to an empty list, and if we print it out, it's an empty list. So the built-in function len, which stands for length, also applies to lists. So you can use this for different data types and also different containment. So this also works with tuples, but it also applies to lists. So since the letters is empty, I'm going to go ahead and use the square variable that we defined above. So we'll say squares, and it prints back 5. So all data types that support indexing start at the 0 index. However, when we're using the length function, it just counts the items within the containment. So for example, the list is a data type. My bad, actually, totally wrong. So the list is a containment for data types, just like tuple. So you can contain data types in here and it just counts them. So 1, 2, 3, 4, 5. So you have 5 items within the containment, and they just happen to be numbers. But it also works with any other type. So I'm trying to see. So we can also do data types. So we'll define that real quick, and just to show you that it works, so we'll say string, comma 1, comma true, comma, we'll say tuple, and then we'll also say 4.5. So there should be 1, 2, 3, 4, 5 again. Boom. Length. Data types. There you go. It returns back 5. So again, it counts the data types that are in the containment. So it's also possible to nest lists inside of each other. So for example, A, comma B, and then we're going to do one more C for that one. Then we'll do N. And it's just going to be a list of numbers. Then X is going to be a list of A, comma, N. And then if we print X, we can see that that is true. So lists or nested lists also support indexing. So for example, X index of 0 returns back the A list because X itself is a list noted by the outermost brackets. And then so index is the list separated by the comma. So this one right here. So you can also do nested indexes. So X 0 1. So what that does is it takes the outermost and it starts the indexes separated by the outermost commas, which would be this one. So it separates them and it says that this list is the 0 index for this position right here. Then it takes the next inner list, and it indexes that one. So 0, 1. So if we return it, we get B. So that's it for this video. If you have any questions, as always, comment down below and I will help you the best I can. Until next time, happy coding.